All right, so we talked about some reactions of alcohols and what you can produce from them, especially the condensation reaction that we talked about. How you can remove a simple byproduct like HCl or ammonia or water, and you can make different esters from there. And we saw different examples of it. Today, the primary reaction that we will be talking about is oxidation. And oxidation can be interpreted in multiple different ways. Obviously, there is the oxidation that produces that involves adding oxygen or removing hydrogen or simply removing electrons. So what we do is we add oxidizing agents, and those oxidizing agents then oxidize the alcohols. And alcohols can be oxidized or cannot be oxidized based on their structure. Now, a shortcut way of remembering this is that you remove two hydrogens and add one oxygen. That is a shortcut way of remembering what oxidation does to alcohols. Again, this is not something you can write in exam, but it will help understand, or in fact, do it right. Secondly, there are some oxidizing agents that we should know about. So there are two that you might know already. There is K2Cr2O7, and we always use it with acids. So we can say acidified potassium dichromate. That is one. And you can also call it potassium dichromate 6. Okay, so this is chromium with the 6 positive charge. That's why it's dichromate 6 and acidified. Similarly, this H positive tells me it's acidified. Similarly, you can use KMNO4, which is also acidified. And these are two strong oxidizing agents. So these are strong oxidizing agents, which can oxidize pretty much anything that can be oxidized. So the color changes are important. Right now it is chromate 6, which means the color is orange. And then it changes to green because it goes to chromium 3 by accepting 3 electrons. Similarly, KMNO4 goes from +7 to +2. So that is Mn in there going taking 5 electrons. And the color changes are purple to colorless. That's how it changes. Now there are two weak oxidizing agents as well. Those are Tollens reagent and Fehling solution. Now the thing with Tollens reagent and Fehling solution is that they can oxidize most things, but not all of them. Okay, so they are weak oxidizing agents, so they will not oxidize anything. Things that are difficult to oxidize, they will not be able to successfully oxidize them. So they're weak oxidizing agents. Exact working of Tollens reagent or Fehling solution is not required in your syllabus, but just know that this one, the Tollens reagent, is also called silver mirror test. So that's also something that's called silver mirror test. So what it does, it goes from colorless to forming a silver coating, and we call it a silver mirror. So here's a picture from online sources to figure out to show you how this works. So there you can see that on the right side it is the way it's originally, and on the left side you see a silver mirror being formed. Okay, and you will see in A2 how this is made and what exactly makes it go from this situation to forming a silver mirror. But right now, just know the color changes, that if it is successfully oxidizing something, it will go from colorless to silver mirror. Similarly, Fehling solution has a copper ion in them. Okay, and because of that copper ion oxidizing, it can change different colors, and the colors are originally it is blue, and then it goes red if oxidation happens. So if oxidation successfully happens, it goes from blue to red. Okay, so just ignore everything else that's there. Just know that it goes from blue to red. So it's blue because of copper 1 or copper 2, and by taking electrons, by reducing itself, it works as oxidizing agent and takes 1 electron, making red solution of copper 1. Okay, so we have 4 oxidizing agents: K2Cr2O7, potassium dichromate 6, KMnO4, which is potassium manganate 7, tolerance agent, and filling solution. Now, let's look at how oxidation happens in alcohols. Now, for that, we have to understand how alcohols are classified. So we know that alcohols can be primary, secondary, or tertiary. So let's suppose I have alcohol prop 1-ol, I have prop 2-ol, and I have 2-methyl prop 2-ol. So you can see that these are primary. This one is primary because the carbon OH is attached to just one more. So this is a primary alcohol. This one is a secondary alcohol because carbon is attached to 2 carbons. And this one is a tertiary alcohol, this one, because carbon is attached to 1, 2, and 3 other carbons. So that makes it a tertiary alcohol. Now, oxidation is you add an oxidizing agent, you might need to heat it, you might need to add reflux if it's a volatile thing. Obviously, most alcohols are volatile, so you heat it under reflux. Now, what happens? You have to remove 2 hydrogens and 1 oxygen. So over here, here's how it happens. So pay attention. Oxidation happens only on this place, not anywhere else. And what happens here is that this hydrogen and 1 more hydrogen are lost. So they're lost. And obviously everything else remains as it is. 2 hydrogens are lost. And this carbon forms a double bond with this one. And this has formed a new functional group that we call aldehyde. This functional group, which we write as CHO, to show that carbon is attached to hydrogen and oxygen. This one, CHO group, that is aldehyde. So primary alcohols, when they oxidize, they convert to aldehyde. Now let's look at the second one. I want to remove hydrogen from oxygen as well as from the adjacent carbon. So in a secondary alcohol, this is where oxidation will occur. And I'll remove this hydrogen and 1 more hydrogen from this carbon. So 2 hydrogens removed, I get. So I've removed 2 hydrogens and now double bond with oxygen. And I have made this thing, which is called a ketone, because carbon is attached to 2 other carbons and there's a carbonyl group. Tertiary alcohol, I need to remove 2 hydrogen, 1 from OH and 1 from the carbon, but this carbon does not have any hydrogen. That means this cannot be oxidized. So the reaction doesn't occur. Now, of course, to show that the oxidation is happening, I'm sorry?
Can you explain the tertiary one again?
So the purpose of oxidation is to remove 2 hydrogen and make a double bond with oxygen, right? So over here in the tertiary carbon, I need to remove 2 hydrogen, 1 from this OH I have done and 1 from the carbon, but I don't have any hydrogen on the carbon. This carbon is attached to another carbon, another carbon, another carbon, and oxygen. It's not attached to any hydrogen, which means I can't remove any hydrogen. And if I can't remove any hydrogen, I can't oxidize it completely. That is why this will not oxidize. Now, obviously, to show that I've added an oxidizing agent, we can use the symbol for oxidizing agent, which is this. So this shows that you oxidized it. You could use any oxidizing agent, and this produces these compounds. The formula for this one would be C2H5 CHO. This CHO tells me that hydrogen and oxygen are attached to carbon. If I wrote COH, that would show hydrogen attached to oxygen, and that oxygen is attached to carbon, which is wrong. This one is CH3, CO, CH3, and this one clearly, or I can also write as CH3 with 2 and CO. This is a carbonyl group, and carbonyl group attached to 2 carbons makes a ketone. And this one stays as it is. Now here's the thing. Aldehydes themselves can be completely oxidized. They can be further oxidized. And when you further oxidize an aldehyde, and this is just something that we will revisit later on, but aldehyde, for example, this one, it can be further oxidized. So if I were to add an oxidizing agent to this, now this will add an oxygen to this. And what happens is that this carbon, obviously it forms a double bond with this, but over here, wherever the hydrogen is, that one gets oxidized to OH. In other words, if I were to rearrange all of this, I will be getting carboxylic acid. So basically, from alcohols that are primary alcohols, you oxidize them. And if the oxidation is incomplete, they will form aldehydes. But that aldehyde can be reacted further and it can be oxidized further, forming carboxylic acids. I can't do that with ketone because with ketone, again, this carbon does not have any hydrogen for further oxidation. So it can't be oxidized any further. And this one I can't at all. What this means is that I can easily use weak oxidizing agents to figure out if I have primary alcohol, secondary alcohol, or tertiary alcohol, or one of them. So for example, if I have an unknown alcohol, the method is, so it's some unknown alcohol. The method is that if this was primary, you add an oxidizing agent, it will form aldehyde. And if it does that, that shows it is primary. Okay. That aldehyde can be further oxidized to carboxylic acid. In fact, if I let the process continue and I want to get the aldehyde out, I don't want aldehyde to react. I want aldehyde to be extracted as soon as it is made. So what will I do? I will take this thing in a boiling flask. So this is my alcohol plus oxidizing agent. I heat this thing. And then as soon as it reacts, I extract it. I let it collect on the outside. If I do that, then whatever thing I'll get over here, and usually we collect it in a conical flask, whatever thing I collect over here will be an aldehyde because I've oxidized it, but not completely oxidized it. But if I were to take this same reaction and instead of getting the alcohol out after reaction, I still heat it, that is still there. But instead of extracting it, I apply a reflux condenser here. Now what happens is that the moment this one reacts, it evaporates, or it is volatile, so it evaporates, it is sent back. It comes back, reacts again, then it's sent up, then it reacts again, then it's sent up, comes back, reacts again, until complete oxidation happens. And this way, this will be converted to carboxylic acid. So if I want to get carboxylic acid, I use a reflux condenser because this is complete oxidation. And if I want to get just aldehyde, I don't want to complete it, I will do simple distillation because the moment I get the aldehyde, I want to get it out. And to do that, I will stop with just partial oxidation. So the general map that we have right now is that alcohol plus oxidizing agent converts to aldehyde, which then converts to carboxylic. Only if this is primary alcohol. If it is secondary alcohol, then it converts to ketone, and that cannot be further oxidized because there's no hydrogen to leave out. And if there is a tertiary alcohol, then no reaction happens. It cannot be oxidized. Okay, so that's how it goes. If you have a reflux condenser, then this happens. If you have a distillation, the aldehyde goes out. That's the experimental setup for this. Okay. So yeah, that's the idea. You extract it, you do it through distillation. And if you do reflux condenser, then you are producing carboxylic acid. Clear? If you do reflux, you will not be able to get aldehyde out anyway. The reaction will definitely go to completion. Okay, so if you want to get carboxylic acid, do reflux. But if you want to get aldehyde, do distillation. So let's do an example. I'm going to give you two alcohols and I want you to oxidize them. So if you've done it right, you'll notice that in the first one, because it's a primary alcohol, this OH is attached to carbon, which is attached to just one more carbon. So this primary alcohol, which means one hydrogen here and one hydrogen here will be removed, and you will end up with this. And if you reflux it, then it will oxidize completely, forming ethanoic acid. Basically, this will oxidize to this. But in the
So
second one, it doesn't matter whether you
distillation
distill.
one again.
Yeah, I'm sorry.
Can you explain the distillation part again? How did you get this from that? Don't you have to remove two hydrogens?
Distillation part is you do incomplete oxidation. You oxidize it to aldehyde, but don't oxidize the aldehyde itself. So when I do that, so for example, over here, the first step to oxidation is remove this hydrogen, and make a double bond here. So when I do that, I get aldehyde. This we call ethanol. But then if I further oxidize it, then this hydrogen is oxidized to OH. And that's what we get here. In the second one, it doesn't matter whether you use reflux or you use distillation, because it will oxidize to just one product. And that is you're removing one hydrogen here and one hydrogen here. So that gives me, everything else remains the same. And just over here, I'm getting two bonds with oxygen. And this is ketone. Clear? Again, the process is important. You're removing one hydrogen from OH and one from carbon. Why? That you will study in A2.
So can you explain the first one, heating under reflux again? Like how did we get that? Like how do
Let's
we...
try to understand what heating under reflux means. Heating under reflux means the component cannot escape. It has to stay in the boiling flask for as long as the reaction is happening. And even after that, it has to stay there. It cannot escape from that setup. What that means is that it will still be there, it will still be colliding with oxidizing agent particles, and it will still have a chance of oxidation. So when aldehyde is formed, that aldehyde is still there. It hasn't gone out. And if it is still there, that means it can still react with the oxidizing agent, which it does. And when you oxidize any aldehyde, you get carboxylic acid. So carboxylic acid doesn't just happen right away. You first make ethanol, and then that ethanol converts to ethanoic acid in this case. Again, because you're oxidizing it in two stages. But with reflux, you're not allowing it to escape. So it has to go through both the stages. It has no chance of escaping.
Okay, so and for oxidizing the aldehyde, we just add an oxygen in front of the H.
Yeah, H changes to OH. Yeah. Okay, let's try this example. Let's say I have one OH here, one OH here, one OH here. Let's see how this will oxidize. If this is reflux, then before you do it, identify this is primary, this is secondary, this is tertiary. What that means is that because it is reflux, this part will completely oxidize. It will convert to carboxylic. So over here, I'll get a carboxylic. Because first I'll remove this H and OH, this H and that H, then I'll convert this H to OH. So basically, on the very first side, I will get COOH. Okay. This is a secondary carbon, which means secondary alcohol. In secondary alcohol, I'll remove this hydrogen and this hydrogen. So when I do that over there, I will get this thing. And this one is tertiary carbons, 1, 2, 3 carbons attached, which means it will not oxidize, it will stay as it is. And there you go. That's what we will get.
Can you do?
Okay.
Can you explain this one again, please?
Sure, of course. So again, before you oxidize, you have to understand that wherever the hydroxy group is, oxidation will happen over there, depending on what kind of alcohol it is. So identify each hydroxy group and identify what kind of carbon is attached to. So this is primary, which means this OH will completely oxidize. Since I have reflux, since I have primary alcohol, it will completely oxidize to carboxylic. So this carbon will completely oxidize. Whatever is happening on the other carbons, this one doesn't care. Then this alcohol is secondary, which means this one will oxidize to ketone. Again, how? Removing this hydrogen, removing that hydrogen, and forming a double bond. Third case, this OH, it will not oxidize because it is tertiary carbon, and tertiary carbon cannot be oxidized. Do you understand this now?
Yes, sir.
Great. Let's try one more example. Same thing, but now we're distilling it. So there's heat and distillation. Now we have to know that there will be partial oxidation. So this OH will oxidize. This is a primary alcohol. So this will oxidize, definitely. I'll remove one H here, one H here, and form a double bond with this oxygen. So I will end up with CHO, sorry. On the second carbon, it will oxidize to ketone. So yeah, I will get that. And the tertiary carbon does not oxidize, so it will stay as it is. Let's try a slightly difficult problem. Again, as long as you understand where the oxygen is and whatever is happening, you won't have any trouble. So again, we have to oxidize this, right? First, identify where the OH group is. OH is here, 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 and here. Then identify that is it primary, secondary, tertiary. So this one is secondary, one, two carbons attached. So this is secondary. This one is also secondary. This one is tertiary because attached to four carbons, so tertiary. So it will not change, it will stay as it is. And this one is with primary carbon. So it will convert to carboxylic. So here's how it goes. So this will not change because it will stay as it is tertiary carbon. Again, I'm not looking at the double bond right now, but we will look at that in a bit. This alcohol will oxidize to ketone, okay? And this alcohol will also oxidize to ketone. This alcohol will oxidize to carboxylic acid. And this one will not oxidize. So that is, as far as we know, for alcohols, the hydroxy groups. But we also know that if there is going to be heat, then the double bond of alkenes breaks down. So this double bond will actually break. And what's on the double bond? This carbon is a secondary carbon, so it will form ketone, aldehyde, sorry. And this one is a tertiary one, so it will form ketone. And this is the overall reaction that we get.
Wait, sir. Can you explain the end again?
Yeah, sure. So you have to understand that there's three functional groups here. There's a hydroxy, there's the alkane part, and there's the alkene part. And all you're doing is you're oxidizing it by giving it a lot of heat. And there's reflux. So basically, there's going to be complete oxidation. So what do alkenes do in oxidation? The double bond breaks down at high temperature and it forms ketones and everything. That is alkenes. We studied that whenever we studied alkenes. So अगर आपके पास कभी भी double bond है, it will break down and oxidize. That is why over here, this double bond broke. This carbon oxidized to HO, sorry, and this carbon, which was tertiary carbon, it oxidized to just ketone. That's alkenes. Alkenes को revise करोगे वो याद आ जाएगा. These are alcohols. This is what we studied today. Secondary alcohol oxidizes to ketone. Primary alcohol oxidizes to aldehyde, which further oxidizes to carboxylic acid. Tertiary alcohol does not oxidize. Tertiary alcohol will not oxidize. Secondary alcohol will oxidize to ketone, and primary alcohol will oxidize to carboxylic acid. Do you understand this? सिर्फ alcohol वाला part याद आ गया, समझ आ गया?
जी सर.
नहीं आया?
सर आगे.
आ गया, ठीक है. Alkenes वाला part we'll revisit it. ठीक है? We can do that next time. Allah Hafiz.